Suppose a jar contains 16 red marbles and 25 blue marbles. If you reach in the jar and pull out 2 marbles at random at the same time, are the events dependent or independent? So the definition, if the probability of the first event affects the probability of the second event, then they are dependent. But if it doesn't affect, then they are independent. So that rule applies, but a lot of times it's easier for students to think in other terms. So for instance, if you can consider the concepts of things that are happening with replacement versus without replacement. So with replacement means you take something out of your sample space, but you put it back in. These are going to indicate events that are independent. And if it's if it's without replacement, so if you take something out of your sample space, but you don't put it back in for the next event, that's going to change things. That's going to make dependent events. So if we are pulling out 2 marbles at the same time, then effectively that's the same thing as the concept of without replacement, because when I pull these marbles out at the exact same time, I'm pulling out the first one and the second one at the same time, but there's no way that I can put the first one back. So while I'm doing that, so I'm doing this without replacement. So these are dependent events, and the reason why. So the first marble is replaced before the second marble is drawn. That's not the case because we can't put the first one back if we're drawing them at the same time. The total number of marbles is known. That is true, but that isn't what indicates independence or dependence. The marbles are chosen at the same time. That is true. And that is telling us why these events are dependent. And lastly, the marbles are drawn from a jar with a large number of marbles. And that's not the case because there's not very many marbles in the jar. There's only 41. Find the probability that both are red. So the probability that if we select 2 marbles at random at the same time and they are both red. And remember, both red means the first one is red and the second one is red. That and in between the probabilities, that is what tells us to multiply. So the probability that the first one is red is 16 over 41, because there's 41 total, 16 plus 25. Now, we assume that the first one was red, and that's been removed from our population, from our sample space. So that leaves 15 red marbles for the second one out of 40 possibilities. So when we multiply these together, do be careful on your calculator. It's generally best just to multiply fraction by fraction so that you don't get stuck with the order of operations giving you a wrong answer. So 16 divided by 41 times 15 divided by 40. You can do 16 times 15 over 41 times 40 if you use parentheses around your denominator at least. But to save parentheses, I find this is a more effective way. So 0.146.